Hello, Peter. So guys, hi to everyone. So let me start. So the other students, I think they will just join us. So today we have to talk about the the last title, which called the library called algorithm, which is also part of the standard template library. So as we discussed in the 10th week, standard template library consists of this several sections. One of them is algorithms. So the containers, about this we already discussed. Functions and iterators, somehow in some minor parts we are also using inside of the algorithms. So the algorithms is a library which holds the list of useful functions that you can use for solving the different problems. So the desktop examples 21. So I have by the sequence we have this such like a folder J3, and let's prepare our file. So the returning 0. Okay. For using those functions, you have to include or import the algorithms library. So include algorithm. So each of these functions in the syllabus, you will have the link to that functions in the official documentation. If you remove this one, you will have the list of all functions which are available inside of the algorithms library. So all of these functions you can use for solving the different problems. So we will talk about some of them which are commonly used for solving the problems, and pay attention that during the exams, so in the term exam and final exam, please carefully read the problem statement. If the problem statement says you cannot use that algorithms, you can in that case you have to implement it by yourself. If in condition statement it says that you have to use some of the existing algorithms, in that case you have to use and solve using this problem and these requirements. Even if you will have the OK status for some problem, but it is not it's not cover the requirement statement of the problem, in that case you will lose a mark. That's why please read carefully again. So we will start from the function called COUNTIF. So all of the functions and definitions examples can be found in the documentation. So COUNTIF, which will get the three arguments, which is the beginning address, ending address, and some function. So like this, similar number of arguments and similar arguments we already seen in the previous week examples. If you remember, when we implement the sort function, we pass it like a plus, so a plus, for instance, 4, and here we are passing the function which is a comparator function, which will compare the two values of that array. Can you remember? So such like addresses, such like arguments, they are the same like COUNTIF arguments. So the beginning and end, it's just the addresses of the spaces. So it's the address of the first element. If it's a container, it's the address of the last element plus 1, and the last one is a count. So what does it mean? So let's implement it. Let's include the vector again. So for showing some examples using the vector. So vector integer v, and we want to fill our vector within the some list of items. That would be the 10 I plus plus, and inside it I want to push push the data, which is the I, to the vector. And for the showing the content of the vector, we want to use again the for loop 10, or instead of 10, we can use the size for now, because we already have the size of the vector. And vi, adding the space between them, and at the end we want to add handle. Okay, let's start the compiling our code. And it says inside of the vector we have this such like variables, such like numbers. So what does it count if did? So the count if will take the addresses of two registers, which means it's the address of the starting and ending point. And count if will take one by one each element which are located inside of this range. So if you read here, it will take the range first inclusively, last not inclusively, which means last one is not included. So it will take each argument of that range and pass this value to your function, which means one value of the item of the collection will be passed to the function. And function should return the Boolean data. It should return true or false. And task for the count if is it will pass each value of that container to your function. And if your function returns true for some operation, your function returns true, it will just increment the counter. And at the end, it will return the number of true cases, which means number of cases when your function returns true for some numbers. That's why here we have the result value, which is the returning part of the count if. Count if, and I want to pass the addresses of the collection, which is we begin and we end, which means I want to look for each data inside of the vector, and at the last argument, I want to pass some function. So function, let it be, so let's create the function. Function should be the Boolean function. Function will take the one argument. Pay attention that the argument data type and the vector data type, they should be the same, because your function will be called for the data inside of your container. Container consists of the integer. If you are getting this here, the string, it will be the incorrect and it will not work. That's why they have to be the same. So your function will take your argument. So each element will be passed to that function. And you have here some own logic. So it might be anything. So divisible by 4. That will be divisible by 4. And we want to return a modulo by 4 equals to 0. So without any if else, you can write like this, which means this expression will return the true or false. So if a number divisible by 4, it will return the true, otherwise it will return the false. So this function I want to pass as a third argument to the count if. What does it mean? Each element will be passed to that function and it will increment the inner counter if your function returns true. In our case, it will return true for the number 4 and for the number 8, which means count if should return the number 2 as a result. So let's run it again. Okay, 3. What is the problem? Problem is 0. It's another problem. It's just a correct case because we missed about the 0, because 0 modulo by 4 is also 0, which is also true. 0 is divisible by 4, which is also correct. That's why it says 3, which means your function divisible by 4 returns true when element is 0 and when element is 4 and when element is 8. That's why count if returns the integer number as a result, like a 3. So count if already exists for a function, but you can implement it by yourself if you want. It's just a simple case. You have to loop over the vector inside it you have to just call the function. So if you want, I can show it. So let's create the function, and we know that the COUNTIF returns some data, which is an integer number. That's why we want to also create the integer function, myCOUNTIF. Let's take as an arguments addresses, 2 addresses, which is this one and this one. So you can, if you are creating the vector as a global variable, you can implement it by the just indexes. If you want to implement the same function like a COUNTIF inside of the library, in that case you have to take the vector iterators. So which means vector integer iterator first, and the second argument will be the same. Second argument will be the same like a last, and the last one will be as we have the function over here, you can just pass the starting and ending point of the vector. And inside it, what we want to do, we want to, using the while loop or inside of the using the for loop, it doesn't matter. We are saying that the first, while the first is not equal to the last one, which means we are starting the for loop, and we are calling the function if divisible. In our case, divisible by 4. So divisible by 4, it's a function, and we want to pass there some value starting from the first one, which means I want to pass the value, which is I have to put the star sign and first. Star sign and first, it's a value of the first argument. And after passing, I know that the divisible by 4, it's a boolean, which is returns true or false. That's why I'm getting like a comparison. So this one, everything will be inside of the if. So if our function for the current element returns true, in that case, I have to count such like a cases. That's why before the while, I'm creating the CNT as always. And inside of the if this condition, so that this function returns true, in that case, I want to CNT++. And after checking the current element, I have to just increment the first, which is I have to go to the next element of the collection. And at the end, I have to return the CNT. So you can call your function again. So let it be the result number 2. And we want to call our function, myCOUNTIF, but without the last argument, because last argument we are implementing inside it. So myCount, beginning and ending of the vector, and let's print out the result 2 also. So 1 CPP, and if you run it, you will have the same result. So all the implementations, so the pseudocode of each functions, you can also see in under the links of from the syllabus. And it says also the iterator, as we did here. We are implementing this myCOUNTIF function by ourselves, and this one is an iterator, second one also iterator. So as you can see, first iterator, last iterator, and the function. So there might be the any function. And inside it again, before the while loop, they are also creating the return value as a 0, as we did here, the CNT equals to the 0. And the same thing what we did here. We're calling the function, passing the value, and depending on the result, if we are leaving like this, it's the same thing like equal comparing with the true. And if so, we are just counting, and at the end we are returning the count value. And it's the same thing. So that's why in the exam, so in the midterm or final exams, there might be the questions like this. So you have some function, let it be the COUNTIF, and your task is simple logic. So you have to count how many times with some logic. So for instance, you are given a list of items, list of numbers, and you have to find number of prime numbers in that list, and you have to create your own function, same like COUNTIF. So as we did here, instead of comparing for the divisible by 4, you have to implement the checking of the number for the priority or not. And this is just a simple case. So you have to understand the logic of the inner part of each functions, which are listed over here. So how it works behind the scene. And you have to know the implementation of so you have to, and you can implement all of them by yourself. So, okay, let's continue. If you have questions, please guys, take a note. So we have to continue. The next example is rotate. For rotating, I want to remove everything over here. So rotating will be the same thing, but the number of arguments are a little bit different. So the middle, so the beginning, end, and middle. So forget about everything over here. And we want to discuss, about it, examples over here. What does it mean return? Rotate. Let's get numbers like this, 5 and a little bit 6 again. So initial list of items, we have such like a list of items. Rotate function will take the three arguments. It's a beginning address, it's a some middle address, and it's a end address. So middle one should be and must be in the range of begin and last. It cannot be the more than last, it cannot be the less than begin. It should be somewhere in the middle. There is no requirement that it should be the exact in the middle point. So it might be any position between these two ranges. So what we'll do if you are passing such like positions? So let's get like first begin is over here, middle is over here, and our last is over here. What we'll do, so let it be the begin, middle is over here. What we'll do, the rotate function will take your middle element, and middle element will be one by one swapped with the first element. At the end of the rotate function, starting from the middle element, all the rest of the elements until the end becomes as a first element of the new list, which means your list after the rotating at the end of all iterations, it should become something like this. Okay, rotating to the right side. You can think about rotating the balls, for instance, if you have just like balls in some sequence with the numbers. If you are rotating to the right side, this sequence, if you are rotating to the right side for one position, which list we'll have the list like 6 becomes here, 1 without 6 here. So this is the initial point. This one is 1 times we rotated our list to the right side, which means last element becomes in the first element. All the elements starting from the first one shifts to the right side for one position. If you are rotating this list 2 times, in that case 5 becomes here and 5 goes from the last. Again and again you can rotate it to the right side. So what does this rotate function? It should, so just guys, just a second. Sorry. Okay. So someone should turn off microphone. Jikijan, I think your microphone is on. No, I can mute it, yes. Okay, so the rotate function will take your middle element, let it be, it's a 4. This one is the result. But if you will take the 1 by 1 by iterations, in that case, in the first iteration, it will just take the elements. So it will be the 0th iteration. It's the initial data. In the next iteration, which is the first iteration, it will just swap the 4 with the 1. First element, swap it with the middle one. And in the next iteration, this number 2 will be swapped with the 5, which means 5 is here and 2 is here. In the next iteration, this 3 will be swapped with the 6, which means 6 over here and 3 is over here. And what was the last one? Okay, and this one is just a final case, final position. After that, we don't have any logic. So if you open the implementation in the rotate, they will do this. They will do the same thing. So the first one, middle one, and last one. So the next equals to the middle, which means it will start from the next element. So in our case, it's a number 4. 4, 5, 6 becomes as the first element of the new list. So if you are thinking about the result, it's a new list. In that case, 4, 5, 6, it's a new list. So what they do, so starting from the first one, they will work until the next. So which means until the middle. So starting from the first element until the 4. So from all these positions, they have to do the swapping elements between the first one and next one, as we did here by iterations. First element with the middle, next element with the middle plus 1, next element with the middle plus 2, and so on. As you can see, we are doing the same thing. So if the next element, if the middle element equals to the last one, in that case, if we left flag reach to the middle one, in that case, they have to be just updated. So the next one should be equal to the middle one. And it should just print, it should just continue. Otherwise, if the first element equals to the middle one will be the next one. If we are starting from the first element, you have to rotate for the one cycle, for getting the initial result. So for that, so let's create here the vector. So to check this function, so we are starting from 1, I becomes until the 6 as in our case, and we push back I, and let's showing part. So we can remove the everything here. Okay. So in the middle, we want to rotate. Rotate starting from the begin. Middle element, as I said before, middle element is just position. So just address between the first and last, between the begin and last element. So as it's an address, I cannot do it like this. V size divided by 2, it's not an address. V size in our case is one number, which is a 6. 6 divided by 2, it becomes as a 3. But you cannot pass the number here because rotate expects the address. That's why you have two options. First one using the v begin and manipulating with them, for instance, +2, or v minus something. We subtracted something. So let's start from the begin +2, which is we are not 2, let it be the 1, 2, 3, 4. So begin +4, which means we are passing the address of the 4 as a middle. And the last element, which is a v and as the last element, and that's it. So what we are passing to the rotate, it's the same thing as we did here. Address of the first element, address of the middle element like a 4. So middle element will be any number between the first and last. And let's see the result. So the 2 CPP, and at the end you have to, oops, is it the second page? Oh, yeah, not should be cout here, isn't it? Should be the cout here, and vi the space, and here should be the v size without any equal sign and starting from 0, isn't it? Second file, and we have to run. So we are passing the 4 starting from the begin, which means adding 1, adding 2, adding 3, adding 4 indicates to the 5. That's why starting from the 5 and 6 becomes as the first element, which means rotating in that position. If you are passing the 3, in that case, you are indicating the link to the 4. It's a we begin adding 1, we begin plus 1, plus 2, and plus 3. For indicating to the 4, you have to add a 3 to the beginning address. And if you run the code, you will have the same result as we did here by the iterations. And rotate will do these operations and these iterations one by one and get the result. So it's an option for when you are using the begin. Again, as I said before, you can use the end, and you can use the end position also. For instance, for using the end position, you have to subtract some integer number, which means if you are putting like a end minus 3, in that case, end minus 1, for instance, end minus 1, it's the last element, it's a 6. If you run using the end minus 1, in that case, only 6 will become as a first element. If you are putting like a end minus 2, in that case, it's the address of the 5. If you are putting the end minus 3 in address of the 4, let's put end minus 4. In that case, it's the address of the 2, which means if I'm putting the end minus 4, in that case, I'm indicating as a middle number 2, which means starting from the 2, rest of the container should become as the first element. No, it should be the 3, isn't it? So the minus 1, minus 2, minus 3, minus 4, sorry, minus 4, it's the number 3. So if you put here the minus 5, it's the address of the 2. In that case, you will have such like a result. Starting from the 2, as you can see, the 2, 3, 4, 5, 6, and 1 becomes as the last element. And this is the task for the rotate function. So we have to move on. Next function is fill. By the name, it can be clear that it should fill some data. It should just feed the empty containers with some data. So we have the empty vector, and fill function says assign the value. So value, it's just a constant data to all elements in the range of first and last. Fill will take the 3 arguments. First, last, they are addresses, and as a third argument, it will take the constant data. For creating the vector with some initial size, you can use a constructor. Let it be the 5. So what does it mean 5? 5 means, for instance, if you are creating a 5 integer like this simple array, in that case, this array can hold only the 5 elements. 6 elements you cannot add. But like so, you can also create a vector with some size, which means vector with size 5. But 5 elements will be immediately occupied, but without any data. But the advantages of the vector and the difference between the simple array, vector can again extend the size. So you can add a 6 element. In that case, it will just, without any problems, it will just add a 6 element and also more. But if you want, you can create your initial size. Why we are putting the initial size? Because we want to use it for function fill. So we're using the function fill. Fill says gets the 2 arguments v begin and v end, and some constant data. Let it be the type. And that's it. So it will do the description data. It will just fill the 5 element with the number 10. It's just a constant data. So in some cases, it can be the very useful without writing the for loop for assigning the same thing. So you can do the same thing, but instead of this one, you have to equal to the constant data and so on. So for CPP, next function is unique. So the unique function, so unique function says you have some data, some list of items. So let's be like this: 4, 4, and 5. So you have such like a collection, and you want to call the unique function to that collection. What unique function does? It will take and remove all elements which are located in a row over here. So for instance, let it be here, not a free, which is a 1 without any free. So for this input, unique will take one by one each element and compare it with the next pair. So it will take the 1, and 1 will be compared with the 1. If they are equal, it will go. So let it be like it. Here we have the pointer. Here we have the next pointer. For the first pointer, it will take the first number and it will compare with the next one. If they are the same, it will change the position of the pointer. If they are the same again, it will change the position. And position is over here and they are the different. In that case, it will take as a second element of the new array like a 2. And it will continue working. And this one, in this case, after putting the 2, left point becomes over here. And right point will be the next element. And they are just changed between each other. 2 and 1. They are different. That's why 1 will be taken over here. And it will change the position like this again. 1 will be changed. So the 1 will be changed compared with the 4, which means 4 is different from the 1. That's why 4 also will take. And after that, pointers will go over here. 4 will be checked with the 4, which is it should just skip it, and the right hand point should change the position to the next element. And they are the difference, the difference between these numbers 4 and 5. That's why it will take the 5. And as you can see, we have here the size of the container will be changed, but unique function cannot change the size exactly. It will just hold the all unique values, which was implemented by the logic of the unique function. The unique function will hold starting in the starting position of the collection. For the rest of the collection elements, will be instead of these question marks will be the same values as in the initial collection, which means 4, 4, 5 will be over here for the unique function. So let's check it. So as we discussed here, let's create here the integer array with those values. Put there the commas. Okay. You can use the address. So as we can see, we can pass the addresses using the begin and end if it's a vector, but you can also work with the simple function, and you can again identify the end position of the simple array. For instance, A is the address of the first one, and 1, 2, 3, 4, 5, 6, 7, 8. A plus 8, it's the last address, which means you can also use the unique function and pass there the 2 addresses. Sorry, like this. 2 addresses, and it says only the 2 arguments we have. So we are saying that in those positions we have some data. You have to update the value of that for loop of that collection. So let's show the elements of the container. So in our case, it's just a simple array. So we want to see out AI. see out the handle. Sorry, handle like this. So the for CVP, and if you run it, you will get such like a result. So I think we have to put here this 8, and here also will be the 8, because we have to put the end plus 1 positions. For instance, in the vectors, so the end, it's the address of the not last element, it's the last element plus 1, because right side is not including. So as you can see here, we have the parentheses, which means not including the last. First one includes, that's why the square brackets. So let's do it again. And as you can see, we have our initial data over here in the simple array, and unique, after calling the unique function, you will have such like a result over here as we did 1, 2, 1, 4, 5. 1, 2, 1, 4, 5. It's just after removing the duplicates which are located in a row. But the rest of the container also hold the initial data. So key point is here, unique function will identify and remove all the duplicates which are located in the row, and as a result, it should return the last element's address of the updated deleted array. So which means unique function in our case will return the address of this 4, which means starting from the first address until the 4, we have the unique elements, which means unique function will return the data. As you can see from this returning part, it says an iterator to the element that follows the last element not removed, which means last element not removed, it's a 5. And unique will return the address of the 4 as the right side addresses is not included in our case. That's why, so when some function will return the iterator or address, you have to store it inside of the iterator, which means you have to, just a second guys.
Can you repeat the question?
No, is another question? Just a second. I have to talk with the. Oh, just a second, guys. Okay, so what was our question? So we are using the unique function. As you can see, we have such like a result. So, so unique function should return some address. So to store the addresses, if you are using the simple array, you have to create a pointer, which is the last lecture about this in our course, which is the pointers over here. If you are using the not a simple array, but a vector, in that case, you have to create the iterator. So I want to show the both of them. So if you have the one simple array, in that case, you have to create the variable as a result. But result is not only integer, it should be the pointer. So this one is a part of the next title, so the next topic. If we are creating the integer, and before the name of the variable, if you are putting the star sign, you are creating the variable which can hold only addresses. Okay, again, you can create the variable, for instance, boolean, okay, equals to something, so without any value. So this okay can hold only true or false. If you are putting the star sign before it, this OK value now can store only the address of some memory in which stored true or false. Okay, I think this is clear for you. So in our case, that's why we are putting here the integer. You cannot put the char, you cannot put the string, or you cannot put the double. So you can, again, you can put the double if you returning address stores the double value. That's why I'm putting here the integer, because our array is integer. So guys, just a second. Okay. So which means unique will not return some simple value like integer number or Boolean number and so on. It will return the address. That's why we are creating the pointer. Which can store only memory address. So this variable, so a result after this line, you cannot result assign, for instance, 10. This expression will not be correct because result is not a simple integer variable. It's the address of the memory in which stored the integer value. Okay, we can move on. So the result is the address of the last changed value. In our case, it's the address of this number 4. That's why for now we are just removing the. So let's leave the sorting. We are just removing the couting using the indexes. So we want to work with the addresses. So that's why let's write using the for loop. It doesn't matter using the while loop. So while our a is not equal to the rest. What does it mean? A, it's the address of the first argument. It's the first element. Rest, it's a value which was returned from the unique. While they are the difference, so they are not equal, we want to print out the a, the value of the a space, and plus plus a, which is we want to after showing the so can I do that like this? So a plus 1. Can I do that or not? Cannot increment the value type integer. How can I get the next argument? So let's create the first, like a pointer. First it's a, like a first a, and first over here, first and first. Can I do that? So I can, yes, I can, because I cannot a plus plus because the name of the variable, name of the array, it's the address of the first argument, but I cannot increment the argument of that. So that's why. So let's try to call the function. So in this case, as you can see, we are just printing out the subset, or it's just a sub array of the original one, which was in which was removed the duplicates without of the remaining part. So this one is just showing the example using the just simple array. Simple array, the unique function should return the address. An address should be stored inside of the pointer. And here I'm storing the pointer of the A, which is the first element, and after that, starting from the first, I'm looping over until the rest, and showing the content and increasing the address of the elements to show the next elements. So I want to show the same example, but using the vector. So to copy all the data from simple array to the vector, you can do the such like operation. So integer v, and inside of the v, you can, if you are putting here some number, in that case, it will just create the temporary 5 elements inside of the vector without the data. But you can copy all the data from one collection to the another collection by passing the addresses of that collections. So what I'm doing, I'm creating the vector, and I'm saying data for this vector, initial data for that vector, located in this range. A, it's the address of the first element, A plus 8, it's the address of the last element, which means after the 19th line, vector V holds all the data inside, which was inside of the simple array. And if so, I'm calling the unique function not using the A, using the V. V begin and V end, as we already know about the starting and ending position. And the returning part cannot be stored inside of the integer pointer, because we are passing here the vector. That's why it should be the address which can hold the vector's memory address. That's why vector's memory address is just the iterator, which we already know. Iterator, let be the F. And this one is not needed for now. So unique function again will remove all the duplicates and return the address, and stored value is F. And for showing the data, we have to start from the VBegin. While VBegin not equal to, let it be the not F, it should be the rest. While VBegin not equal to the rest, I want to show the elements of the. So we begin. Let's create here another iterator. So iterator, which equals to the VBegin. To change the positions, I have to create the iterator. Instead of VBegin, I have to put the name. It should be the IT. IT over here. While IT is not equal to the rest, I want to show the value of the IT, and instead of this first, it should be the IT. IT value will be to just change it, which means will be the same thing as we did here using the simple array, but now we are working with the vector and showing the same result. 5 CPP, and if you run it, you will have the same result. So that this part can be, this can be removed. Okay, let's move on. For each did we, so we just unique. So yes, for each it's just a simple, one of the simple functions which can be used, and I think if it's not necessary to use that function by this problem statement, so you can just implement it by yourself without any function. So the for each is just a function which, so just remove it. For each will take 3 arguments again. First one is starting address, ending address, and last one is a function. So the function is just a simple function which will implement, which will take each argument of the collection, each element which located inside of this range, and these arguments, these values will be passed to your function. And that's it. So let's do it like this. Very simple one. Void function will take the integer value and just see out it. out it with a space. And that's it. So function will take the one argument integer, y integer, because we have the integer values inside of the vector, and we'll just see out it. Function, this func was passed as like this. And after that, if you run the code 6 file, it will be just print out the elements of that vector. But as you can see, we are passing the addresses of the first and last element. And in other words, you can think about it like we are writing the for loop. We are writing the for loop, and last argument function is just the body of the for loop. So that this part is just a separate function over here. But you can do in many other operations in that function, but it depends on the task. But the key point is, for each one, we'll work with the addresses, and for each element, it will call your function, and that's it. It will call your function, and without anything, it will just implement it. So the next part. Next function is generate. So generate function. So let's remove everything over here. That'll be 10. Generate function. We will take the three arguments. First, last, as always, they are the addresses, and last argument, which is also function, like for each, but the function, this gen function should return the value. So when I'm writing the for loop like this, starting from the 0 until the v size, so I plus di equals to some constant data. So it's just example. So it should be just somehow the constant data. So this type of the code you already know. So looping over the vector, so the size we have, looping over the vector and assigning vi, assigning some data. So we are assigning some value to each of the vector, and you can write such like a code, and fill the vector with some data. What will do the generate? It's just the same thing. So you can just close this one using the generate function. You can pass the vBegin vEnd, and as a third argument, you can create the function. Let it be the gen. So the gen function should return the same data type as your vector can store. It's an integer, that's why it should be the integer. It's a gen function. And inside of the gen function, if you are returning the constant value, in that case, it will again will do the same thing as we did in the fill function. Where is the fill? Fill is over here. So we are passing the begin and end and passing the constant value, which means for all elements, I am assigning the value 10. But here we have the more flexible option. So gen function can be implemented by yourself. And if you're assigning the number 10, in that case, you will have the same result. Oh, sorry. See out. So we forgot about the for each. For each, in our case, it will just show the content of the vector. As you can see, if your function returns the integer number, like a constant number, it will be the same thing like a filling. So you can fill it using the number 10. If you comment this line, it will be the same thing. So what is the difference between the generate and fill? So generate, it's just a function which can get the not constant value but the function. But inside of the function, you can create very different numbers. Let it be the c equals to the 0, c equals to the 0, and here we have the result every time plus plus c, which is incrementing the value of the c and assigning like a values. As you can see here, in that case, you will have the numbers from 1 until the 10. But this logic is just example. You can create any random number of, so the random values inside of your generate function. It depends on the task. You can generate any data, and those data one by one will be assigned to the values of that vector. So we want to continue the generate function, but before the generate function, we want to talk about the generating the random numbers. So we move everything over here, everything over here. How can we generate the random number inside of the C++? For that, we have the function, the library called cstdlib. So first of all, you have to include it. So after including the cstdlib, you have the such like options, such like functions which can be used in your program. And one of them is rand. Another one is srand, which is also very connected to this function rand. So after importing this one, you can immediately call the rand function. So if you run the code, cpp, in that case, you will have some random number. If you run it again, the result will be the same. So in the previous group, when we discussed about it, I was asking the one question. Let's imagine that you are passing some interview to the IT company, and interviewer asks one simple question. Can you generate the unique number? Can you generate unique number and say it? So which number will be the unique? What do you think? What will be the answer for that question? What is a unique number? Unique means if I cannot say that 10 is unique. I cannot say that the 1 billion is unique. I cannot say that the minus 10 is unique. What will be the more correct answer? Any ideas? Can you say the unique number which will not appears in the future? So the unique number that I guarantee that in the future this number will not be generated.
No. No.
Sorry. Say it again.
No.
Null. Sorry. Say it louder.
Нет.
So this is a not number. So the correct solution, we have the correct solutions. That's just a question, but I think it's just a logic question, which you have to think about. So question is, tell me one number or some data which will be the unique for forever. Some data which will be the unique forever. Any ideas? So we have 10 seconds. So I'm waiting for the results.
Constants like number pi or e.
So the number pi is a constant number, but the tail of the number is also will be the same if I'm calling counting the pi. If I'm counting the pi 2 times, second time will be the same result as the first. But this contradicts to our question. So the printed number or showed data should not occur in the future. In the future means in the second line it cannot be the same number.
Are you talking about the index?
So index of what?
Like a for loop I index
No,
of the array.
just forget about the for loops, forget about the count if, or forget about the random numbers. So question is simple. Question is, can you tell me some data? It might be the number, it might be the anything. Can you tell me some data which is unique forever?
No, because every number staying alone, they cannot be unique.
So you can
Maybe, we can
need
define,
some-
maybe we can define uniqueness of element in the list of numbers.
So guys, the question I will try to paraphrase the question. So forget about the numbers, forget about everything. So question is, can you tell me some data, something? So okay, it might be the number, it might be the some string, it might be the char, it might be the any data.
Element of the set, because there are only unique elements.
So I think the question was something different from the programming or from the Programming Principles 1 course. So question is, you have to tell the unique number. So unique number or unique data. I think you already know about it. So what is this? What is ticking on the right side of the corner? Top right side.
Date.
So in your life, 27th November 2021, 16:45, 16:45, 03 will not be again occurred, isn't it?
Yes.
Do you agree? So the time is unique. So every second, every millisecond. So if it's a second, there we have the milliseconds, which guarantees that after the sum time, after the sum, if it's a minor time, it doesn't will be the new data. So when the question is, say me the unique data, it's a time. So the time is very interesting thing. So you have to be careful for spending the time for the needed data, so the needed jobs. So that's why don't waste your time for the unnecessary cases, unnecessary things, because as you can see, the time is not recoverable. It's just data which will be the continue ticking and ticking, which is also unique. So now we have to come back to our code. So what I'm talking about, if I'm calling our program, I'm calling the function rent, but it always will return the same data. Same data, which means it cannot generate the different numbers because our program cannot identify. So the run function itself, inside of the run function, it will do some mathematical operations to identify the data. The range of the run function will be between the 0 and rand maximum. Rand maximum, it's just a cout. So the rand maximum is just the integer number which can be stored inside of the integer data type, which means 2 to the power of 32. It's a maximum number. Sorry, it's 2 to the power of 32. It's a maximum number, and this number is a maximum which can be stored inside of the integer. So, and this number is pointed as a random maximum. So this function, so the rand function, always will return the some data, some number between the 0 and this number. But every time when the rand function returns some data, it should do the sum calculations. It should do the sum calculations with something. So comparing with the something to get the unique data. So the random function should return the different data depending on the sum calculations. For calculations, there might be the, for instance, let it be the integer or 100, and result, so the integer of the result of the random, let it be the random like this, r plus 100, so multiplied by 3 divided by, let it be the 4, it's just example, plus something and modulo, that would be the 30. So let's imagine that for generating the random number, we have the such like an expression. Such like expression, so this number, if it's a constant number, the result will be always the same, isn't it? If the r is 100, and this calculation will be result again and again when I'm calling this number, when I'm calling and executing this expression result will be the same every time. Do you agree with me?
Yes, of course.
So that's why to generate the random numbers, basically in most cases, instead of this r and instead of this constant, will be the time data. What is the time data? Time data is just the integer value of the current time. Integer value of the current time, which is every time is different. And that's why if this number every time is different, in that case, random will be also the different numbers, isn't it? In such a way, will be generated the random numbers in any programming language. So what we are talking about. So in our case, rand function returns the one number. To configure our program to see to the time data, we have the second function which is called the srand. Srand is a function. So the random number generator is initialized using the arguments passed as a seed. So in your program, you can call the function srand, and inside it you can configure it to syntax will be like this. The time, it's a function which is also inside of the stdlib. You can read about it over here. So the time, so the c time over here. Time and putting the or null or 0. Let me put like this. Null. So what does it mean? So the 14th line says, in our program, we want to use the date for generating the random numbers. So after the 14th line, when I'm calling the rand function, every time it should return the current date time, current date time, and use for generating the random numbers. After that, let's compile it and call it. This number, as you can see, they differs. I'm calling it different number, and so on. Every time when I'm calling, it should take the current date and generate, so they calculate some expression and return me the random number between these two ranges. Okay, I think this one is clear. So if you copy this line and put it before the srand and compile it again, as you can see, you will get the same results every time for the first element, and the second one might be the same if you are running very quickly your program. Why? Because we are using the time. So let's try it again. So as you can see, when I'm running our program very quickly, so I'm getting so in the program of the rand, so inside of the rand, so it cannot get the whole data of the milliseconds. So in some cases, I can catch the moment that the time data will be the same, and that's why it should return the same. But if you have some little bit delays between the calling functions, in that case, you will get the random numbers. So, okay, question is, so you have to generate the numbers between 0 and 10 using the function rand. What you have to do? So if you run the rand code, rand function will return. Rand function will return such like a numbers every time, which are the difference, but we want to generate the numbers between 0 and 10. Any ideas? How can we do and how can I get such like a result?
Random percent 10.
Yes, perfect. This one is correct. So the random
one.
number, which is this one, and percent sign, which is a modulo by 10. What does it mean? So I'm removing all the all the divisible part to the 10, and will be remaining part from the 10 will be the exact what we need. So after calling it, you will get the 0, 7, 4, 1, and so on. Okay, so next question. Next question is, you have to generate the random number between 10 and 20. 10 and 20. Any ideas?
Random percent 20 plus 10.
Random percent 20 plus 10.
Maybe.
So I want to call it. What does it mean? It's a divisible part for the 20. I'm just missing. I'm just skipping. And after getting the so this part, so that this part will be always less than 20. Less than 20, and after that, I'm adding the 10, and here I have the 23, which is not inside of this list. Any ideas?
Остаток отделения на 10 плюс 10.
So it should be the 10 over here and plus 10. Isn't it?
Yes.
So let's try it. So I'm calling. So what does it mean? You have to understand. So this part, what will be the maximum value and what will be the minimum value? So the minimum value will be the 0. In that case, the result will be the 10. So the maximum value will be the 9. So maximum value will be 9, and in that case, will be the 19. So that's why when I'm calling the 19, 16, 13, 10, so on. So the next question is, what will be the range? How can I generate the range, for instance, years from the 2000 until the 2021? Any ideas?
Остаток от
Divide.
2000 плюс 107.
Yes.
So the remaining part from the 2021. I'm looking from for this case. So is it correct? So it's not correct, yes. You have to think again. So we have to take the numbers between these two ranges.
No, remaining by 21 plus 2000.
So this one should be the correct, yes. So it's an H file. So in that case, this should be the correct, yes. So what I'm doing, so I'm getting the 21's remaining part, which means the numbers which are generated over here. So that this part will be the always starting from the 0 until the 21. It will be the until the 20, not 21. 21 will be the 0 until the 20, and plus we have here the plus 20. Sorry, 2000, and in that case you will have the such like a result. Okay, using the random function, you can generate any type of the ranges. So it depends on your task. So I will come back to the generate function, and instead of this counting the C, we want to, just a second, guys. So guys, what we are talking about. So we want to use the generate function. So let's remove everything what we don't need for the fill also. So the gen function, in our case, in the last example, we use the counter. So instead of the counter, we want to generate the number, random number. For generating the random number, we have to include this library. Oh, sorry. Why I into example? This one is over here. I have to create a new one. So instead of this ++c, this one is not needed. So we have the vector with the number of elements is 10, and gen function should return the random number. For that, I have to use the library for the srand times 0 for generating the new data every time. And inside of the gen function, I want to use the rand. Let it be the percent sign, 100 and +1, which is a 1 and 100. So the random numbers between the 1 and 100. Percent sign 100 is the data from the 0 until the 99, and adding the 1 will be the from 1 until the 100. So let's call it 9 CPP. And if you run it, you will have the 10 elements which are generated using our function, using our generate function. And the numbers will be the different every time. So here I have the 100 is. Okay, let's move on. We have so how many functions we have? So generate about random. So the last function which we want to talk about, it's a next and pref permutations. So before the permutation and before the functions which we have to discuss, let's try to understand here what is a permutation. 1, 2, 3. So what is a permutation? Permutation, it's just a number of possible combinations of some data, some sequence. So let's imagine that we have the 3 students with the ID number 1, 2, and 3. And question is how many possible positions we have for these 3 students to rearrange the order. So the first one is 1, 2, 3. Second one is 3, 1, 2, or for instance 2, 1, 3. We have the 3, 2, 1, and so on. How many elements, how many positions we have, how many possible cases we have? Any ideas?
Maybe 27.
Sorry?
6, I think.
6. So it's just from the simple
The
math.
factorial of the number.
Yes, perfect. It's just a factorial of the given number. So the number of items, how many students we have. So those number factorial will be the all possible cases for rearrange the order of that students. So in our case, it's a 3 elements, 1, 2, 3. That's why the 3 factorial, which is a 6. We have at most this fixed 6 combinations of the changing the order of that students. But here we have the question. The question is, which we are talking about which we are talking inside of the next and pref permutations. So these functions will generate the permutations which are lexicographically greater permutation. What does it mean, lexicographically greater? Which means we can read about it inside of this on the link. So if you are thinking about it like a 1, 2, 3, it's just a minimum number. What will be the nearest greater number, greater sequence for this one? Any ideas? Nearest greater sequence.
1, 2, 3.
1, 2, 3, it's the initial one.
1, 3, 2, sorry.
1, 3, 2, perfect. So for this sequence, nearest next permutation or next combination, which should be the greater. It's a 1, 3, 2. Do you agree with me?
Yes.
Yes.
Okay. Okay. Can you find the next nearest permutation for this sequence?
2, 1, 3.
2, 1, 3. Why 2, 1, 3? Why 3, 1 is not nearest?
Because in this case, we should change two position and two.
Yes, that's
two
why.
actions. Two actions.
Yes, two actions. So, in our case, so for this position, after the disposition, the next nearest permutation will be the 2, 1, 3. Why? Because if I'm comparing the numbers one by one, so the 1, 1, they are the same. So the 2 and 3. So the 3 exactly is greater than 2. That's why. So the last element can be just not changed. So they can be just not compared. So the 3 is greater than 2. That's why is next permutation is greater than the previous one. But we cannot generate the one more greatest, which will be the greater than 2 before. So that's why 2 becomes from the initial one, 2 becomes for the first position, and 1, 2, it's the next permutation. So the next greater permutation from this one in areas
2, 3, 1.
3, 1, isn't it? So 2, 3, 1, it's the next permutation which is greater than from all of these previous sequences. And the same thing for the number 3. So the 3, 1, 2, and 3, 2, 1, which is a last permutation for this number of items. Can you generate after this one new permutation which will be the greater than the last one?
No.
No. Why? Because it's just the maximum what we have for the permutations, which will be the greatest permutation. So this one is a minimum permutation, which is just the maximum permutation what we will have. So if you count, we have here the 6 combinations, and which is a 6 combinations over here. It's a 3 factorial. It's just a part of the simple math. So what will do this next permutation and pref permutation is just to identify can we find the next, or can we find the pref permutation for that cases. And this is just a simple explanation. So let's create the simple array, which is a 1 to 3, and we want to find the next permutation. So the next permutation and pref permutation, they will return the Boolean value. So that true if the function could rearrange the object as a lexicographically smaller, if it's a pref. For the returning part of the next permutation, it should return true if the function could rearrange the object as a lexicographic greater permutation. If I'm passing this sequence to the next permutation, it returns true. Why? It returns true because we have the next permutation for that. If I'm passing this last permutation, so the last sequence to the next permutation, it should return the false. That's why basically we're using the do while loop for showing the elements of the array. So in our case, it might be the cout. We have only the 3 elements. That's why, or you can write the for loop, or you can write by yourself. For instance, A1, and after that we have here the so A2 as the last element, and endl here. So we have 3 elements of our array, and we're doing this action while next permutation, as we got from the documentation, it should return true or false. If it returns true, in that case, I am showing again and again permutations of that case. So the next permutation will take the 2 arguments. It's the starting point and ending point of the any collection. In our case, it's a simple array. That's why A is the address of the 1, and A plus 3 is the address of the 3. So let's call it. And if you run it, you will have all possible combinations and permutations of that. So let's try to call the next permutation for the numbers like in the range of numbers like 2, 3, and 1. So this position. And in that case, if you run the code, in that case, you will have only the 3 last permutations of that sequence. Why? Because next permutation will generate only greater permutation and try to identify it. For the last item, if you are writing here the 3, 2, 1, in that case, it will run the code, will just one times print out the data, and our next permutation will return the false, which means while loop stopped working. So that's why 1, 2, 3. That's why if you have the task for identifying the all possible permutations, for instance, in your midterm, end term or final exam, if the problem statement says find the all possible permutations, in that case, key point is you have to sort given data. For instance, if you are entering the data like this 1, 2, 3, 2, 1, 3. In that case, you will got the permutations, but not all. As you can see, not the 6 now. That's why, if so, you can to identify the all permutations, you have to sort it. If it's just a simple integer array, you can sort it using that like this. If it's string, also you have to sort it, and after that try to identify the permutations. And in that case, you will have the all possible actions. For instance, if you have here the number 4 and passing the 4, and you have to put over here the space and next element. How many possible cases we have for the 4 numbers?
You should change in next permutation a plus 4.
Yes, I forgot about it. Thank you. How many elements we have? How many combinations we have for the 4 people?
24.
24.
24.
So here I have the 24 lexicographically greater ordering permutations for the 4 positions. 1, 2, 3, 4. 1, 2, 4, 3. 1, 3, 2, 4. So about it, you have to think and you have to understand what is going on inside. Just a second, guys. Okay, I think this one is clear. So we want to just come back to the 3 elements to show the pref permutation. So I think here we have the 3, and I want to copy this part and put it over here. And instead of the next one, I want to use a pref permutation. So the arguments are the same, so the actions will be the same, but the function is pref. Pref is just the opposite of the next permutation, which means if you are saying that the positions of the elements is 2, 1, 3, which is over here, 2, 1, 3, pref permutation will identify the lexicographically less permutation from this one, which means current sequence, previous one, and previous one until the possible case, which means it should return such like results. 2, 1, 3, which is the current one. It's a 1, 3, 2, it's the next one, and 1, 2, 3. It's the most less permutation for the given item. So it was the last topic which we have to discuss today. So time to your questions, guys. Please raise your hand and Yes, you can, but you have to raise your hand.
Oh, I'm sorry.
So question from Arthur, yes.
What will be if we put in our array only, for example, only tens or only ones for одинаковые элементы, в общем.
What will be for permutations? It will not change, it will not work, and it will just print out the same results one time, and that's it.
Okay.
If the elements are the same, in that case, we have only one. So you can think about the permutations as a real case, so the probabilistic case of the mathematical point of view. For instance, if you have the 10 people with the 10, with the same IDs, and your task is to find the different order cases, you cannot generate a new one. It will be just the one case when they are just somehow located in some order, and that's it. If the numbers are the same, in that case, we have only the one permutation, which is a simple initial position. Arthur?
Okay, I have one more question. Which library we have to include to use this function? Can you show, please?
For using the next permutation, all of them located inside of the algorithms. So we are talking about the two libraries. First one is algorithms, which will hold all of these. So for instance, count, if rotate, field, unique for each, generate, all of them located inside of the algorithms. For using the random number, for generating the random number, we included the cstdlib. cstdlib, from that library, we are just, so you can remove it in this case because we are not generating the new item. So for using the random and setting the random configuration and so on, you have to use the cstdlib, and that's it.
Okay, thank you.
Yeah, any other questions, guys?
Can I ask?
Yes, you have to just raise your hand. So
in our midterm or in our end term, will we expect task related to struct? Because our last topic was about
the last topic will be in the next week. Last topic will be by the syllable will be the pointers and structs. But we will discuss it with the teachers. But I think after the next week's lecture, after the one day, you will have the midterm exam. That's why the last topic we will just skip it. So the problems will be before the 12 today's topics, including today's topics, will be the last problem statement.
Okay, thank you.
Okay, any other questions, guys? Questions might be in any language, please. So today's topic is just the last topic for the end term and final exam. So that's why you have to be ready for solving any type of problems, including the first attestation and second attestation during the end term and during the final exam. Please be ready for using the QBTU's computers, PCs. If you are already in the Almaty city, in that case, please, I recommend to prepare yourself to use the university computers in Abla Hana site in the first floor. They will have the resource room. In that room, you can access the computers of the university, and in those university computers, you have to try to solve the problems. So here I have some instructions. So you have to use, as in the midterm, you will use the CPP SH online platform for writing the code. And if will be the problems with that online source, you have to be ready to use a dev CPP, which is already installed in the university PCs. So that's why be ready for both cases, for creating the CPP file and passing and sending it to the system and so on. Canserik, please, question.
Surely, question about related to this. Can we practice on university computer's keyboard on Dev CPP? And where we can?
So
where we
I talked about it. So if the resource room, which is in a first floor from the Ablayhana site, I think the resource room should be opened. So if we have some problems with those rooms, in that case, you have to just ask from the dean's office any computer rooms. You can just select some room from your timetable. So the intern timetable you already got. So from those rooms, any of the rooms can be opened for using the ID card of the managers from the dean's office. You can ask them to prepare yourself to the KBT's computer. So I think the resource room in the first floor of the Ablayhana site will be always opened if it's a working day. So you can also practice yourself in that computers. So I think there's requirements and the rules of the exam is clear. The exams are clear to everyone. So the practice problems have the 7. So the rules are the same as the midterm. We have the 6.5 score for each problem. As a maximum, you can earn the 45 points. But if you are getting the more than 30, in that case, those numbers, those points will be just skipped, because by the rule of the university, we can only put the 30 as a mark for the attestation. Why we are getting here the more 15 points, because it's just possibility to get a more data, so that more point for the internal exam. So that's why if you earn the more than 30, in that case, we can only put the 30 as a maximum, which means from these 7 practice problems, if you already solved the 5 problems, you can guarantee that you will have the maximum point for the second attestation. So the rules are the same. So the KBT CMKZ, where will be the link and translation and documentation of the C++, which we are showing during the lecture time. So any other questions, guys?
Oh, coach.
Yes, any other questions?
No
Oh.
questions, that's all.
Okay, if you don't have any questions, I want to just add today's examples to the GitHub. So what was topics or algorithm? So I just the examples to the GitHub, which can be accessible for everyone. Okay, in that case, I can just stop the recording.